everyone, Katrina here, and today I'm going to teach you all about Pythagorean Theorem. Be sure to watch to the end to see the full example and subscribe for more videos like these. Okay, I have many videos out right now about trigonometry, identity, trig ratios, and all of them seem to come back to this fundamental concept of Pythagorean Theorem. So I thought I'd make a video just to show you exactly what it is to alleviate any confusion you might have. So Pythagorean theorem applies in a special case. So we can use this theorem when we have a right angle triangle. So that is very important. If you do not have a right angle triangle, so right angle triangle means that you have at least one angle that's 90 degrees, or in radians that would be pi over 2. So you have to have a triangle that has a right angle in order to use Pythagorean theorem. So in this image that I have written over here, you can see that this angle that I'm highlighting is a right angle, so that means that it is 90 degrees. So Pythagorean theorem allows us to find the side lengths of our triangle if we have one angle that's at least 90 degrees. So at its most basic, definition, Pythagorean's theorem says that c squared, which is our hypotenuse over here, is equal to a squared, which is this one side length over here, plus b squared, which is our other side length over here. So then that helps us find a missing side length. So if you have 2 out of the 3 side lengths here, you can solve for the third one. So I'm going to rearrange this equation into 3 different ways for you right over here. So let's start with c. So say we want to find what is the value of our hypotenuse. So that is going to equal to the square root of a squared plus b squared. What if we want to find a? So a is equal then to the square root of, we'd have to rearrange the equation here, so it would be c squared minus b squared. And then finally, if we are looking for side length b, we can write it as the square root of c squared minus a squared. So this shows us the relationship with our side lengths. But Pythagorean's theorem extends a little bit more. If we've established already that we have a right angle triangle, we can also learn something called SOHCAHTOA, and that kind of dives right into our lesson about trigonometric identities. So I'm going to give you a little bit of a sneak peek right now on SOHCAHTOA, just so you can take that knowledge with you when you're solving trig equations. So let's look at that. We have SOHCAHTOA. So SOHCAHTOA is a way to remember the trigonometric identities. So say we consider some angle over here. So we're going to just look at this angle over here and denote that as theta. So the angle opposite to theta is our O, so that's our opposite. The angle adjacent to our theta will be our B, so we're going to call that capital A. And then the hypotenuse we'll just label as H. So for this tells us that sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, and then tan theta equals to opposite over adjacent. So this helps us if we have one side length and one angle, we can find the other side length, or if we have 2 side lengths, we can find an angle. Whereas this first one over here for Pythagorean's theorem, we need at least 2 sides, and then that allows us to find the third side. So this is just a great relationship that we have once we have a right angle triangle. There's so much we can do here. So let's go through an example of using Pythagorean's theorem, and let's see what we get. So for example, let's say that we have this following triangle over here where this side is equal to 3 and this side is equal to 4, and for this problem we want to determine what is the hypotenuse of this triangle. So essentially, if we're going by our previous labels, we have side length A, we have side length B, and we are looking for side length C. So we know that c squared equals to a squared plus b squared. So then c equals to the square root of a squared plus b squared. So in this case, we know that a is 3 and b is 4. Therefore, c equals to the square root of 3 squared plus 4 squared. And what does that equal? We've got that c is root of 9 plus 16. Therefore, c is root 25, and the square root of 25 equals to 5. So that means that our mystery side, our hypotenuse here, is equal to 5. And we're able to use Pythagorean's theorem to solve this because we have a right angle triangle. So be sure to always remember Pythagorean's identity. It comes up very often in trigonometry. And also be sure to remember your SOHCAHTOA. If you have a right angle triangle, then you can use these amazing side length ratios to solve your trigonometric problems. I hope you enjoyed this video. If you did, please drop a like and definitely subscribe for more videos and check out the full trigonometry playlist. I'll see you next time.